Alright, hey everybody, this is Mr. Lokinen, and this is the first lesson for Chapter 4. I know you're all super excited to start Chapter 4, so am I. Chapter 4 is all on this, what's called congruent triangles. Alright, so Chapter 4 is talking a lot about triangles, and what we kind of get into is how we can prove that they're congruent. Remember, congruent means the same. Alright, so the first lesson is all about right here, classifying triangles. Alright, where we're going to talk about different vocabulary for triangles and all that. It's going to be a good lesson. I will have to hurry up because, as you can see, I'm awful at charging my iPad and I'm only at 6%. So hopefully we can get this done before this thing dies. Alright, so first thing we're talking about, classifying triangles. We can classify triangles in one of two ways. We can classify them by angles. 5%. Classify them by angles, or we can classify them by sides. So those are the two ways that we can classify by angles. You've all done this in the past a lot of times. Let's just kind of review. We call a triangle either an acute angle, an acute triangle, like this, an obtuse triangle, or a right angle. Alright, and maybe the one that you haven't heard a whole lot of, this is called an equiangular or equiangular triangle. Alright, so acute triangle means one of those angles, an acute triangle means all three of those angles are acute. An obtuse triangle means one of those angles are obtuse, like this. Right angle, one of those angles is a right angle. And then equiangular, all angles are the same, like this. In order for them to all be the same, they will need to be 60 degrees. Alright, so that's classifying them by angles, and then we can also classify triangles by sides. Alright, so there's three different types. There's what's called a scalene triangle. Scalene is when you have all three sides are different lengths. Like that's an example of that. Then we have an isosceles triangle. Isosceles is when two of those sides are congruent, like this one. And remember, those little tick marks represent that they're the same length. Alright, so that shows that those two sides are of equal length. And then we have last what's called an equilateral triangle. That's when all those sides are congruent. We show that by making those little tick marks, showing that they're the same measurement. Alright, so that's how we classify them by angles and sides. Next, if we were to look at this figure and have to try to identify an isosceles triangle and identify a scalene triangle, there's a couple of examples. I'm just going to write down one. We have to indicate an isosceles triangle. Remember, that means triangle that two of the sides are the same. So I'm going to make that triangle right there. Line it up. Perfect. Nice. So to represent that triangle, we would say triangle ABD. Alright, perfect. Next, we have to identify a scalene triangle in this figure. So three sides all being a different length. I'm going to do this triangle right here. Now I would represent that as ABE. There's a lot of different possibilities. Those are just one of each. Remember, scalene, three different sides. Isosceles, two of the same sides. And then also equilateral would be all three sides being the same. Next, we have this figure here with each side given by an algebraic expression. Alright, so what we're asked to do is find x and the measure of each side of this equilateral, and that's important, equilateral triangle GHI. Remember, equilateral means all of those three sides are all the same length. Alright, so what we can do, since I know all three of these are the same, that means like this and this are equal to each other. Alright, so if I know they're equal to each other, I can set them up as an equation, set them up equal to each other, and then we can make an equation, and then we can solve for x. So that's what I'm going to do. So I would just need to solve for x. I could subtract 3x from both sides to get 0 equals x minus 5. Add 5 to both sides. we get x equals 5. Alright, so that's one answer. Alright, we found x, but also it says find the measure of each side right here. So what you would need to do is you would need to plug in you would need to plug in 5 for x. You can actually plug it into any one of those three sides since they're all the same. I'm just going to plug it into that 3x. So 3 times 5 will give us 15. Alright, so each side will give us 15. Alright, each side is 15. Sweet, there it is. And then if it were to ask us what's the perimeter, you just add those up together and give you 45. But it's not asking you that. If it would, that would be the answer. So, we'll move on. Pause that, write that down. Next, we are going to have to classify the triangle. Alright, so oftentimes, remember, whenever you see classify, you have to make sure you read the rest of the question. Alright, because it's either going to ask classify the triangle by the measure of its angles or the measure of its sides. Alright, it's really important. If it's angles, it's either going to be the acute, obtuse, or scalene. No, what am I talking about? Sorry, acute, obtuse, right, or equiangular. Alright, but if it's by sides, then it's going to either be scalene, isosceles, or equilateral. Alright, and it's good to use your notes as you do the problems for these, so you can refer back to that. So, what we have to do is we're measuring by its sides. Alright, so we're trying to figure out, is it either going to be scalene, isosceles, or equilateral. So, how we're going to do that is we're going to find the distance of all three of those sides. So, this one is A, B, and C. So, these three points that are given are drawn on this as a triangle. We have to classify it. So, measure of AB is square root of 85. I'm going to write that. Next, if we were to figure out the length of BC, that's what we can do next. We can go BC equals, and we're using the distance formula, we're going to go x2 minus x1. So 2 minus a negative 1 squared plus negative 4 minus 4 squared. Alright, 2 minus negative 1 is 2 plus 1. 2 plus 1 is 3. 3 squared is 9. Negative 4 minus 4 is negative 8. And then negative 8 squared would give us 64. Alright, so the answer then would be the square root of 73. So BC, square root of 73. And then next, I'll do it just down here in this space. So AC, the points are negative 3, negative 5, and then 2, negative 4. So I will go 2 minus negative 3, and then that's squared, plus y2 minus y1. Lots of negatives there. Square root of all that. 2 minus negative 3 is 2 plus 3, which is 5. 5 squared would give us 25. And then negative 4 minus a negative 5. Negative 4 plus 5, which would be 1. 1 squared is just 1. Alright, so add those up together and you get your answer of the square root of 26. We'll write that down. Alright, so we have all three of our side lengths. Square root of 85, square root of 73, square root of 26. And then you can figure out what type of triangle it is. It's three sides that are all different. So I'm going to say scalene is a scalene triangle. Good stuff. Alright. The explanation, all three sides are of different lengths. Alright, so that was it for section 4.1. Yeah, that was it. So, any questions? make sure to let either myself or Mr. Hanson know, and we would love to help. And that's it. Check it out. Finished it with 3% left. Nice. Alright. Thanks for watching. I will talk to you later. Peace.